Good morning, everyone. Apologies for the difficulty getting things started. My name is Candy Daffin. I'm the Florida Department of Transportation's CAD Training Coordinator. Welcome finally to the ORD Curb Ramp Civil Cells webinar, part of the CAD Office's ongoing series of webinars on hot CAD topics. Your presenter today is Zachary Billings. If you have questions during the presentation, please enter them into the Q&A dialogue. We will do our best to answer these questions in real time or take a moment at the end to review any unanswered questions. These questions and answers will be compiled into a Q&A document, which will be posted along with a recording of the webinar on our website. If you experience any additional difficulties with the audio, the easiest way to fix that is to log off, check your audio settings, and log back in, as we don't have control over the client-side audio. And I appreciate everyone's patience while we got today's issues resolved. And now I'll turn things over to Zachary.
All right, thanks, Candy. All right, we'll just get started here. We're talking about ORD, curb ramp, civil cells. And civil cells in general are really helpful and time-saving way to model elements that you need to place over and over again. So we're thinking of things like curb ramps and driveways and any other situation where you might have to place the same exact thing over and over again. And so basically, instead of modeling each one of these things individually every time you come across them on your projects, it's a great idea to create your own civil cell library and model them once so that they can be placed basically anywhere in any project that you have currently working on or in the future. So what we'll cover today is, first off, creating a civil cells DGN lib. And then you also want to create a civil cells ITL file to go along with that. So the ITL file is your template library. So you're going to, in creating civil cells, you're going to want to use corridors and templates, and that template library will hold the templates that you're going to be working on for your civil cells. And it's also important to save these files in the correct location, which I'll show you how to do. So once we get that DGN lib loaded up, we need to learn about the appropriate things basically to create a civil cell. Things like reference lines, ruling of elements, using corridors and templates, and then actually creating the civil cell. And then once you've created a civil cell in your DGN lib, you can close out of ORD and reopen it back up to have ORD reload that configuration so that it will now see your civil cells, and we'll learn how to place a civil cell and seamlessly incorporate it into other corridors. So usually in this instance, it's going to be something like a curb return corridor, or sometimes we'll have it where a curb ramp is maybe just in line with the mainline roadway if you're crossing a street where you've got like a T intersection or something like that. So we can check that out too. And just in case you guys don't know who I am, I'm Zach Billings. You've probably seen this slide a million times, but we'll just get right back into it here. So I've got Open Roads Designer open to my, I just called it this model RD99 civil cells. And let me show you where that is. So if I bring my File Explorer over here, most of you, if you're doing a workstation installation, you've got this FDOT Connect 10.12 or 10.11 or whatever it is folder. It doesn't really matter if it's 10.11 or 10.12 or 10.10 for that matter. It all works the same way. You want to go into that folder, go to Workspaces, FDOT, Standards, and then this is where you can start placing any number of things. Like I've got a cell library in here that I use. If you go into the DGN lib folder, we've got a civil cell folder. So if you place a DGN lib in here that has civil cells in it, the FDOT workspace will read anything with a DGN lib in this, a DGN lib type file in this folder, and load any civil cells that are in this file when you load Open Roads Designer. So this is where you want to put that dgen lib in your civil cells ITL file as well. So that's basically where you want to put that. So I'm already in this file, and I just wanted to start kind of taking a look at some of the curb ramps that I have created in here. So I've got a bunch of different ones. Let's start with the CRB. So I think what's really important to do initially is to learn how to create a 2D civil cell before you even worry about the 3D portion. So that means that all of this is 2D. There's no corridors, there's no 3D elements assigned to this. And basically the reason I'm doing this is to make sure that I can create all of the 2D elements so that the civil cell will actually create. So usually the way you would start is I've got like a blank template down here. I've been working on a new CRF down here. This is actually one of the trickier curb ramps to do, and I'll explain that once I get over to this one. But I've got basically a blank template here. So what these are going to be is your reference lines. So this is a reference line for my edge of pavement and a reference line for my back sidewalk. And when I begin creating this civil cell, I want to make sure that every element that I create is some sort of child of these elements, or is ruled to these elements in some way, or is ruled to a child of a child. You're basically just making sure that all of your ruling is based off of these two elements. You can't have anything else floating out here that's not ruled to anything. So you can see like these elements are just floating in space. They're not they're not ruled to anything. So that's the first important part. And for curb ramps, you'll notice that I did draw them on a curve because that's kind of important. They're curb ramps. I'm sorry, I said curve. But most of the time we're placing curb ramps on a curve, so you would ideally make your civil cell on a curve. Now I've built one up here that's on a tangent. I talked about that too. Sometimes you run into T intersections or you want to do that. So I've got a couple different types. And so you'll see that I made one that is for, on this side of the road. I called it northeast, southwest. And then I've got another one that's on this side of the road, northwest, southeast. So when I create this one and make it a civil cell, if I try to put it on this side, no amount of tweaking the direction of the reference lines makes this work. So I basically end up having to make it on either side of the road. So this one could be placed, on this edge or this quadrant of the intersection. Like if there was if we're talking about a bigger intersection, if there's another side street that comes down here and comes down here, this civil cell would go down here. This civil cell could go down here. So you basically need to create two different ones. So let's go over some of the thought processes here. So I have a edge of pavement here. I just drew like a 35-foot radius, just drew an arc. Then I also have a line that I kind of tried to draw it perpendicular to the edge of pavement, but I didn't use the tool line from element because I don't want, or I'm sorry, by angle from element, because I don't want this element to be ruled to this element in any way. So these are my two reference lines. So everything else is sort of built off of those lines. And if you've seen any of my other videos and stuff like that, I use a ton of construction lines, and this is kind of why, because I'm basically trying to make sure that all of this stuff gets ruled properly. So the way a lot of this stuff is set up is I've got a 2 foot 5 inch that way, 2 foot 5 inch that way. So I'm basically making sure I have a 5 foot landing down here. And then that's kind of what sets up all of this stuff. So there's actually you can see this construction line back here. So that's my backup curb essentially is ruled off of the edge of pavement. So my edge of pavement. And then this line, these green lines are basically working as limits. Basically, I could change this number to, this is 15 right now. I could stick this thing way out here to 20 or something. I basically just tried to make it so that it creates boundaries for this thing, because I want to, it's using this curb back is ruled. So I've got 15 feet here, then I drew a biangle from element from the edge of pavement ruled to the end of that point, so that I can kind of stop this line within the limits. If I offset this the entire way, this line would go the entire length of the curb return, and I don't necessarily want that to happen. So that's why this rule is kind of bounded by this 15-foot wide on either side. And so when I offset this is 6 feet, so that's your regular sidewalk width, that's from the curb. And then we've got another one that's 7 feet, so that's my ramp. And then I've got another one here that's 4 feet, so that I've got the 4-foot landing that goes around the ramp. So we'll talk about that in the 3D, but you can see that everything is ruled to everything else. Like you'll see everything kind of has snaps. And then when we get to stuff like this, these are single offset partials. So that's how this one started too, is it's a single offset partial of this line. And then it's snapped to the begin here, and it comes out 2.5 feet. This one comes out 2.5 feet. So I've got my landing. And then these guys are 7 feet because that's how long this is. So I'm trying to make a triangle. And that's just how everything is being created. So it's really a good idea to think about all of the rules. Let's go over real quick how to create this civil cell. So I've already got this civil cell created. But if I come over here into my Explorer and go to civil cells, let's find this is called, that's why I put these pieces of text up here so that I know exactly what these things should be called. So this is CRB 2D, Northeast, Southwest, CRB, Northeast, Southwest 2D. So if I click on it, it lights up. There's a couple different ways you can drop a civil cell if you want. You can come up here to model detailing and drop civil cell. I like using Explorer. I feel like sometimes when you use the button up here, sometimes it doesn't work. Maybe that's just an old thing and everything does work now. But I usually just come over here and drop civil cell. So if I drop that, okay, so now it's no longer a civil cell. Like if I hover over this one, should say, usually it doesn't really tell you, does it? Oh yeah, there it goes. Belongs to CRB Northwest Southeast 2D. So it's saying it belongs to that civil cell. So when I hover over this one, this is just now no longer a civil cell. So usually I just double click on this and copy the text. And then you want to come up and create civil cell. So I'll paste the name of my civil cell. Now it starts asking you to locate reference elements. So I'll come down here and I'm going to locate my first reference element, which is my edge of pavement. And you'll see that it lights up. So when that lights up, that means that all of those elements are children of this line in some way. But I still need my center line element to bring it all together so that I know exactly where everything starts. So once I've got that and everything lights up properly, I can right click and I don't have any optional references, and then I can accept. Okay, so now I've created that civil cell. So we should see CRB Northeast Southwest 2D over here again. Come on. Getting a little spinning. Anyway, I'll explain what I'm going to do next while this spins. So when I created that civil cell, there it goes. We have our references in here, and it basically just call the reference whatever the feature definition name is. So basically, when somebody goes to place the civil cell, they're going to see it's going to ask for construction lines white dash. Like, what's the first reference? It should be construction lines white dash, and people, if they haven't designed the civil cell, they're not going to know what the heck that means or which reference they need to click. So I come in here and I rename these, and I just call this EOP, edge of pavement. And then the other one, I just call this ramp CL, okay? So let's just place that down here, for example. So I'm just gonna use this one because obviously I gotta use it on this side, but I can show you what'll happen if I try to place this one on this side. So let's try that real quick. We're gonna place a civil cell, and we'll come in here. So I'm clicking the little dots. I know I have dark mode. There's little dots in here. It's kind of hard to see in dark mode. So right now I'm using active DGN, but if you're in another file, you will see down here the name of this civil cell. So when I go into another file later and use this, you'll see that I select them down here. But for right now, they're in this active DGN. So I want CRB Northeast Southwest 2D. Okay. So when you click this, you can see in red the reference lines that you need to expect to see. And actually, this one's not even set up right for this. I need to draw. So let's draw. So when I'm doing my reference lines down here, when I'm actually going to place it, it's okay to have lines that are ruled to things. So like if I put it here, let's just do 90. So there's the reference line I need for this CRB. So we'll go back and try and place that. Place. Should already be in, no, didn't save it because we didn't place it. CRB Northeast Southwest 2D. No, Northeast Southwest. Okay. Or wait, I'm placing the wrong one. I need Northwest Southeast. Oh, I was going to show you why it breaks. Man, I'm all over the place. Okay. Did not fix. I fixed it. Northeast Southwest 2D has that. Okay. Northeast Southwest 2D. You can see how it gets a little confusing with the names. So here it's asking me for EOP and then ramp CL. So you'll see like it wants to put it on the outside, and you'll see that you can view alternatives by clicking on the elements, and that should try to flip them. Looks like this one's actually going to work. I think it was this one that was not working. So maybe that you can do this. Some of them you'll be able to, some of them you won't. I know this one was being a big pain, and I created this 2D civil cell and tried to place it over here, and it was just not having it. So you'll have to, I mean, I guess that's a good lesson, is you're just going to have to test and test and test again with your civil cells to make sure that they work. And so as I'm creating this 2D civil cell, a lot of times I'll come in here and try to create the civil cell even before I'm done, just to make sure that I can create something. Because if something's broken, you want to catch it early on so that you don't get to the end and then have to go all the way back and figure out what's broken, especially when you get into the 3D stuff. So let's take a look at doing at this 3D civil cell. So let's bring this one up over here. I'm used to working on my wider monitor here. Got to squeeze everything in. All right. So you can see that we've got the sidewalk here. We've got 6-inch concrete sidewalk because this is a curb ramp and a return. So that's going to be 6-inch concrete sidewalk. That's important. We've got our curb coming through here. And you can see that the curb drops down to drop curb in here. And so in order to do that, we've got to drop the curb face down, but we've also got to push this curb face out to meet up with the gutter right here. So there's a couple different parametric constraints that handle that. We've got to drop the curb back down. And then it's important that, this is something I've been working on recently, the back of the curb piece right here is on the same slope as the ramp. So as this ramp comes down, it matches this slope here. So I guess you're probably asking, like, well, how do I do all of that stuff? That sounds like a lot. And it is a lot, which leads into why you want to create civil cells in the first place. These things take time to create because there's a lot of thought that goes into it. There's a lot of parametric constraints. There's templates that you need to create. And so if you can do it once and get it working, then you can use it over and over again. So we can see here, let's get into my corridor. It's probably, let me open up my template library first. So if I got to open up my template library because you'll see like it's not finding a template library. So I've got to load my civil cell template library. And I'm getting a lot of spinning today. Sorry for all the spinning, but come on, template library. Anyway, if you don't, yeah, it's project-wise. Project-wise is bumming me out. All right, so I can get to my civil cell ITL right here. I want to make sure that is my active template library, because if I just clicked on that corridor and opened up my corridor objects, they probably would have been blue because the active template didn't have the templates that I need. So now that I've got it open, I can just close it real quick. And we'll go into our corridor objects, click on this, and everything looks good. They're not blue, they're not red. If they were red, that means I changed something in my template, and I need to come and synchronize that. So you can see I've got 3 different template drops, or 2 different template drops really. 2 of the same template, and then the ramp in the middle. So this one I did because I wanted to make sure that this curb back piece here was on a vector offset of this guy right here. So let's look at these 2 templates and I'll show you how they differ slightly. So we're gonna go look at CRB left. CRB left. So we'll look at the ramp sides first. So we've got our regular curb ramp in here. And you can see I've got curb, I've got this piece that is the ramp, and then I've got the landing back here. So the intention for this is to be able to have this curb face dip down and hit this curb flow line as the ramp comes down. So if I look at this point, you can see I've got its horizontal 1.5 from the ref point, so from the edge of pavement, and it's vertical 0.375 from the edge of pavement. But I've also got these labels here that allow me to use parametric constraints in my corridor objects to adjust this over a distance. So once we get to parametric constraints in the corridor objects, I'll show you how this gets adjusted over the distance. So let's go, there's a couple points that are sitting kind of right on top of each other here. And I've got a curb back out and a curb back full. So this point, I'm basically keeping where exactly the curb back would be if we didn't ramp down. So it's 2 foot from here and it's 0.375 up. So that's, your standard standard plans curb F. But if we go here, this curb back, the one that I want to move, has a curb back height label on it so that I can drop this down as needed. So basically this point as we go through the ramp is going to go from here to here, and this point is going to drop down to here and try and match the slope of the ramp. So then if we go to the curb ramp, this is always going to stay 2% from that curb back full. That's why it's important to have that curb back full point, because this point doesn't change. It's going to be this vector right here that's going to change, and it's going to go from where it is here 2%. It's going to drop down to something like this and slope up. Okay, and then that's got a label on it too if you need to change the backside with the cross slope at all. I've got a horizontal feature constraint on here, which would allow me to do an external reference, but I don't typically use that. And then we can go all the way out to here, and this is the same thing. You may notice that I've got this width is 12 feet. Maybe a good idea to even make this even more. So what this is doing is I've got 7 feet, and then I need another 4 feet for a landing. So I think that's why I made it 12, so it's 1 foot beyond that landing. And essentially, because I've got this horizontal feature constraint here where it's looking for back a sidewalk, and I make this point further out to the left than I need it to be, so that with this range, I'm looking back 12 foot to the right for any back sidewalk external references that I add. So that will allow this, when it tapers back in, to come this way. You could shrink it down and look left, but that gets a little tricky because then it's hard to see what's going on in the templates. Like you'll see in some other templates, like my curb B, I think I pulled this all the way out to like 16. But then as long as I set my horizontal feature constraint and range to the same distance that it's out, it'll look back to the right. Okay, let's see. I think that's all for that point. And then you'll see some of these other points. You might notice that some of these are not exactly vertical. And I'm setting these up so that we can use some of the newer tools to create top and bottom meshes from our components, essentially. Now, top mesh is pretty easy to make. Most of the time, you don't have any vertical faces in your top mesh stuff. Like your curb has like a little bit of slope in it here, so this isn't exactly vertical. But in a lot of the bottom mesh stuff, we've got a lot of vertical faces. And so what this is trying to do is if you have vertical faces and try to create that bottom mesh, you run into a lot of issues because it will not create a mesh that has vertical faces. So all I'm doing is offsetting these points just a tiny bit, like horizontal 0.01, and then this point is 0.01 from the point above it, so that this isn't a vertical face. And then you might have noticed I've got these other weird elements over here. I would call them backfill components. And this is something that FDOT has taught before as well, is to use these backfill components. So what I've got here is this would be the bottom of your pavement. So I've got a label in here that you can use to do your pavement depth. And that's a parametric constraint you could add and set this to your pavement depth, because obviously it's going to change depending on which project you're working on. And it's just this little tiny sliver. So the intention in here is we would have pavement that comes down to here. So this would be the bottom of your base. And then there's this little tiny sliver that has a non-vertical face right here. So this point is just right on the bottom of the curb. It's just slid 0.01 to the left to create a tiny little sliver. And the same thing's happening over here. So I've got this at the curb back just to not make a vertical face here. And then I've also got this created so that if you have, sometimes we have projects that have curb base. So if I flick this thing on, it turns the curb base on. So that's another parametric constraint right here. If you wanted to turn the curb base on, you would just add a parametric constraint and add this and say anything other than 0, basically. So if you make it 10, it'll turn the curb base on. But you'll notice it also turned off the backfill element that's right here, because this ideally should go to the bottom of the pavement. And it turned off this backfill component here and turned this one on. So I've basically got, there's a tiny little sliver here. So I'm basically making a non-vertical face between that point and that point. So I'm trying to build these things so that they can be used in a variety of situations. And that's the reason for like switches and all of these labels. And it gets kind of tricky to handle a multitude of different situations, but that's kind of the point of the civil cell. You want it to be able to be used in multiple types of situations. So let's like test out this point control here. So if I test, let's test vertical, it's going to ask us which one. It doesn't, come on, test vertical. All right, let's move this up a second. I'm just going to put this up at 0.5 a second. So you see I put that point up at 0.5 and it moved that one up. Let's test this. So as I test this, if this drops down, you see how the ramp slopes. So basically we're going to end up getting to a point somewhere right about here. And then we'll have our ramp. And so you can see how the ramp goes up and then this stays at 0.2. Okay, move that down there. So just move that back down. And then the other ramp is only slightly different, where this is just where I've already got the curb drop down. So you can see I made a direct copy of this. I just made a few modifications. So I got rid of, the curb face out point because I don't need that. And then I adjusted this point right here to still be 2 feet from here, but now it's on the vector offset of the ramp. And so if you're not familiar with vector offset, that is if you make a vector or a straight line between 2 points, in this case, left curb ramp and left curb flow line out, I'm telling this point to stay on that vector. So I'm 0 offset from that vector. So if this comes up, let's just test that. Test point control vertical. So as this comes up, you see how the curb back adjusts too. That left curb back out will adjust with it. So that's really the only difference between this one and this. And I also came in here and I did a quick test. If I change this to vertical, so it's 5, 8, 4, 3. Why is this one different? That's strange. It's like 5, 8, 4, 3. I got a slightly different number, but I'm basically trying to figure out, like, when I do my parametric constraints to drop the curb back from its full height down to this height, what do I need to use? I'll have to look closer at that. There might be some little measurement off somewhere that's making that 5, 8, 4, 3. Okay, so I'm going to close out of this and not save because I don't want to do anything with it. So let's go take a look at all these parametric constraints that I've added. And first, I guess you can see that how I've dropped the templates. So I've got the ramp sides that goes from the beginning all the way up to the edge of the ramp. I've got ramp left here. That's the actual ramp portion. And then I've got that for the end. So we've got some parametric constraints in here. And so I've got curb face height, and that is going from the standard 0.375, and then it drops down to minus 0.125, which is 1.5 inches below the edge of pavement line, which is where our gutter is. So it's basically dropping down to there, and then so that goes from here to here. In this range, I've already got it set up like that in the template, so I don't have to add a parametric constraint for that. And then there's a curb face height going out of that, so from 0.125 up to 0.375. We've got our curb face offset because we want to make that face go from its standard offset of 1.5 and flare out. So you can kind of see what it's doing here. It's going from, I've got a 5 or a 6-inch top of curb here, and then it flares out to go to the bottom of the gutter. So instead of 6 inches, we've got 8 inches here. And so this is just measuring the other way. So 1.5 from the edge of pavement, and now it's 16 inches from the edge of pavement. And we do that twice. We do it coming down the ramp and then going back up, because in this area, I don't need a parametric constraint because it's already handled by the template. And the last one is this curb back height. This is the number I was talking about here. This is the number I got before. I'm not really sure what I did with the template that screwed that up, but this is the number that I got before. So that should be the slope of the ramp times 8 inches. So whatever, that's where this number comes from. So I'm going from the height of 0.5 down to, we're going from there down to there. So that's where I got that height from. And then coming back out, we're coming from here to here. So when you kind of turn this thing on its side, you can see how the curb face kind of flares out and goes down. You can see how that curb back portion is at the same vector as the ramp, and everything's flowing into itself. So one of the things that I really want to do in the future is be able to evaluate the slopes in here. So like I'm drawing everything as if it's just a standard curb ramp. But right now I would just need to put some profiles on a few of these things, like a profile on that point, that line, and that line to determine like, okay, what is my slope? Is this steeper or flatter than 1/12? And that's going to be completely dependent on the profile of your curb return as well. So if your curb return's doing some weird things and it's really steep, or it's got, you know, a curve on it or whatever it is, you want to be able to evaluate, well, is this long enough? Is this 7 feet long enough for my curb ramp to come down at a 1/12 or flatter? And so I would just need to come put some profiles on here and check that. And I know that's a big topic of conversation because I think a lot of people want to use these civil cells in situations where you're doing like retrofits and stuff like that, where you've got to be able to test those things. And so it's pretty simple for me to just come in here and put a profile on this thing, because I've already it's already there basically. And so you would just be able to come in here and open up the profile view of that line and see what the slope is. And if it's less than, what is it, 8.667, I believe is 1/12, then you're good. So I'm going to take a look at some of these questions a minute because I've been seeing them come up because I've been talking for a long time. All right. 3D cells typically use up memory. Looks like some of these have been answered in here. Consider using only one template. Yeah, I mean, you'll see. So for this one, I decided the question is, have you considered using only one template and controlling the variables with external references and or parametric constraints? Have you considered using only one template and controlling the variables? Oh, it's just doubled up, sorry. So for this one, this is a situation where I did use 2 different templates, but really it doesn't, I used 2 different ones here because basically what I was talking about here is it's not always going to be 8.667 slope here. It could vary. So that's why I wanted this particular piece to be on the vector offset of here. And then you could come in here and figure out what the vector offset is and slightly change these 2 parametric constraints to match what your actual slope is. And then you'd have, you know, this thing coming down perfectly. It might not, I mean, it's really close, but it might not be exactly perfect, you know, to the decimal point. But if you've got some situation where it's way less or way more than 1/12, you'll definitely see it. So that's the, what is this, CRB. So that's one of the, that one I do have 2 different templates. But if I come over to the CRC, this one I only have 1 template on this one. So if we slide over, because I know when I get down to here, this landing is going to be 2%. So when I go from here to here, that's going to be 2% for sure, always. My varying slope is here. So when I'm talking about this particular one, there may be situations where we've got to increase this distance from 7 to something a little bit higher to make sure that we've got a 1/12 that comes down here. So you can see this one's slightly different. It comes down here, we've got this, but this one has a little header curve at the back. Looking at my time here, I've got a couple more. I think we're gonna go to 11:15, so that's what I'm assuming, as long as everyone can stay on, because I do want to have a chance to kind of show you guys how to use these things. Let's take a quick look. Oh. Okay, I'm just gonna keep going. So let's look at CRC, look at left. And this one has these little, I've got to build in this header curb. And it's pretty similar. I've still got that curb back out full because I want that point right there to always be 2% up. And then I'm just going to move the curb back out full up out of the way a second. So you see how that bumped that up. And then if I test the point control here vertically, see how as this drops down for the ramp, I create that little header curb there. And so from this left curb back out to the sidewalk curb face bottom out, I've got that 2% locked in there. And so if I drop this down to, what is it, 0.02 times, I just put this in my calculator just a second ago, 0.02 times 8 inches is 0.0133. So if I drop this down to 0.0133 above that, then I know I've got 2% between the left curb flow line and here, and then that'll be 2% as well. So that's really the only difference, is this is going to drop down and create this little header curb at the back here. Okay. And this also has all that extra built-in stuff with the curb pad and all the backfill components. And that's pretty much it. So let's go on this one. So this one does have a couple more parametric constraints in it because I've got to put parametric constraints through the ramp portion here. So I've got 3 curb face heights, 3 curb face offsets, and 3 curb back heights. So that kind of answers the question that we were looking at before, is I use 2 templates on the other one because I have a varying ramp slope there, and I want to make sure that my curb back is on a vector offset. In this case, I know that it should be 2% here, so that's why I can use 1 template. And it's kind of basically doing the same thing. We're going down full curb face height down to the gutter, at the gutter level through here, back up to full the curb face offset. We're going from our normal offset down to the gutter offset, staying at the gutter offset, and then back up. And then our curb back height right here is exactly what I was just saying, where we're at 0.5 and then down to that 0.0133, which is 0.02 times 8 inches. And then we're down there through the curb opening, or the ramp, and then back up. I don't know if there's no external references for this one because it's pretty straightforward. So that one's probably the easiest one. Let me see if I had, because I know we were talking about external references. I think there's some external references for the curb back sidewalk. So there's this one. You see there's a bunch of back of sidewalk lines that are referenced in there. And I've got all my curb ramp lines as well. So that in this case, I was using that curb ramp to follow these purple lines. So you see, like, these two in particular are pretty easy because everything is directly perpendicular to the radius of the curve. And I just started doing this one the other day, and I did end up creating it. I still need to do it on the other side, but this one gets really tricky because the ramp is nothing is perpendicular to the radius. So in this one, there's a lot more point controls and profiles and things of that nature to get, this to slope down. So you can see like how it gets a little tricky here, but I did end up getting everything to work. That kind of rounds in real nice. We've got a nice landing here. So, I've got a lot of civil cells in here. I've also got a CRD. And since we have about 15 minutes, I want to go check out an actual file. So we're going to close out of this. Let's see. How to add 3D to this. Okay, so we've got a question in here. How do I add 3D to the 2D civil cell to make it a 3D civil cell? Good question. So I suggested starting with your 2D civil cell. Make sure you can get that created. And then once you get that created, you can place your 2D civil cell basically right below it like I had on your test section, your 2 lines there, and drop the 2D civil cell that you just placed. Keep the original, and then you can start using your 2D civil cell line work to build your 3D civil cell. So that's how I've been doing it. Always do the 2D first, and then work on the 3D, because then like, okay, I've got all the 2D lines work now. Now I can move on to making the 3D stuff work. Have you attempted to use civil cells for guardrail approach and trailing ends? I haven't really needed to use that because I feel like a lot of times when I do that, I just have a template that is like a barrier, and kind of similar to what I would do with the curb there, like dropping everything down to make it match. Because usually like you have that 25-foot transition from the full height barrier down to the curb. I basically have similar labels and parametric constraints set up to allow me to dip that thing down and make it come and match the E curve. And then it's more that for me is more like manipulating templates and stuff to get all that to work right. It's really hard to model a guardrail end treatment too. So usually I just show it all as guardrail up to the end of the end treatment line. Okay, how to add template. Okay. All right, I'm gonna try and answer some of those questions at the end real quick, but I wanted to get in here. So what I had already placed some civil cells in this, and I went ahead and deleted them out. So you can see I've got sections chunked out of here. And the way this is set up is I've got a corridor here already for this return. And you can see there's a little gap here. So I've got one template drop that goes from the beginning to here. Then I've got another template drop that goes from there to the end. And I've already got some line work set up here. So this is going to be the CR, is this the D? Let's see. So I want to go to my model detailing, place a civil cell, and tighten over here. So if I click my little dots again, because I've got my library in the right spot, see it shows up down here. So I can open up that guy and we can do D. Let's see, this is northeast. What is this? I'm trying to get my bearings on where I am here. This is northwest. Okay. So I've got a CRD set up here where sidewalks wrapping around and then we're shooting them across like this. So you can see it's asking me for my EOP. So I've got this here, and it should say profiled there. I need to go change that. I will put a little note on there. Oh, it does say profiled. Just drop down to the next line. So it says EOP under in parentheses profiled. That's to let you know that this does need to have a profile on it when you do this. So I'm going to click that, and then ramp near edge. So this is a little bit of a tricky one. This is kind of how this CRD is set up. So that's why I've got this red line here. So that's the ramp near edge. And we got to flip the direction and flip the direction. Looks like some things are not working right for some reason. Anyway, let's just place it, see what happens. Did I choose the wrong one? Maybe I got to choose the other one. Seems like that was the wrong one. Good point though. If I want to come in here and delete this civil cell, it's still here. I can delete this whole thing and delete it out, and now it's gone. So let's try place civil cell. So I was doing northwest, southeast. Let's try the other one. CRD, northeast, southwest. EOP profile, this. Yes, that's what happened. So I was using the right one. I guess that one's somehow got messed up. So this is what happens when you place it on the wrong side. It gets all sorts of screwed up. So I'll work on that one later. I had it working because it was in here at one point. I must have screwed something up when I was playing with it earlier. So let's do, let's see, this was the CRC. That one's a little easier. See, that's how tricky these things can be and why it's important to test them, because I've been messing with these since I knew I was doing this webinar, and I honestly didn't have time to test it yet. But I only really modified the one that I had that was working, so it's interesting that it doesn't work, and I have to go figure out why it doesn't work now. So let's see, this is southwest. This should be here. EOP, ramp CL, flip. All right, so that one looks good. So now I can reset and left click to accept. All right, so that guy is in there nice. You can't even tell it's, I just filled in the gap here. So the important thing you want to do is, with my other corridor here, see this end isn't ruled to anything. So if I pull this back, I can create this gap. And there's a green construction line in here to signify the end of or I guess the beginning of this curb ramp corridor. So I just want to come in here and grab the end of this template drop and rule it to there, so that if this line ever changes, these things slide together. And then do the same thing on this end. So this one's, let's see, snap. So you can see now it's ruled, okay? So you can see that's just seamlessly in there now. So let's do the create a place civil cell. Let's see, CR, we want to do CRB. This is this one. So we're going to grab our EOP again, ramp CL. Might have to flip it. Nope, we're good. So I can right click to accept, boom. Places that in there. Why is that not picking up my external references? That's interesting. Doesn't want to pick up external references. It was fine in the other thing. That's really strange. Anyway, if that were to work, let's see what's going on with it. I'm interested to see if it just didn't. I mean, we just looked at this. It had external references in it. They're all here. That's really odd. I don't know. again, it's something else I'm gonna have to look into because it makes no sense. They're all here. Northwest, southeast. Oh, I think I know what it is. So this is a case of where they're looking in the wrong direction. I used the wrong civil cell. Which one is it? CRB. Delete that guy. So my horizontal feature constraints are all looking in the wrong direction on that particular one to try and find those. That's why they're not working, because I placed the wrong civil cell. Again, another reason why I have to make civil cells on both sides. And it's important to pay attention to where you're at. So I was doing B, northwest, southeast, northeast, southwest. Here. Let's flip it. There we go. Yes, live demos. Somehow I keep messing it up. Anyway, we'll get that sorted out. And that's basically how it all works. Again, I would want to button up these to snap to here again so that if anything adjusts, it all moves together. But that's pretty much it. Sorry that one didn't work for some reason. I'll have to check into that. It could just be something to, it's definitely something to do with that horizontal feature constraint and it looking in the wrong direction for my external references. But I'll look over here at the questions and see if we've got anything else. So we did that one. So we got the question that I knew we would get about making this available. And obviously you don't want it right now because it's broken, but once I fix it, FDOT is looking into potentially adding this to the workspace, and we will keep everyone up to date on that in the future. Reading through civil cell libraries such as shared. How do you create your own civil cell library? Oh yeah, I think you answered it. The DGN line. You just basically you can create a brand new empty DGN file, like use create file, create a DSGN RDO1, and then copy it to that location that I mentioned, change the extension to DGN lib, and go for it. That's pretty much all. Is the intersection itself a terrain model or part of the curb template? For this one, sometimes I do a few different things. This one is a terrain model, but I could also do it where, I guess that would be trickier too, because I would have to include the pavement as part of my curb ramp to go out and find like this edge and this edge, so that would be trickier. So in this case, that's just a terrain model. Access ramp. Vern and I did talk about that a little bit, but I'm not really familiar with that tool. So we will get back on that question. I'll talk with Vern and the people at FDOT and see how they feel about that, and we'll come up with an answer for that. Are all the elements from the civil cells being placed into the file that the cell is placed? Yes. So and if so, have you had issues with element names changing? Yeah, I mean, not really, because it's just going to create, like, if I placed another civil cell in here, it would call it 1, and I think it just starts incrementing things, and it should be smart enough to figure out that things changed. I'm still confused as to why these external references don't work. But I think, these numbers look different. Let's see, like it looks like it put the name, it appended the civil cell name to the original name. So I think that's how it's getting around the names changing, is these are now, they have the civil cell name before the actual name of the component as it is in the template library. So I think that's how they get around that, and so that would alleviate that issue. I think I got to the end of the questions, and it's 1 minute short, so
It turned out wonderful. Thank you so much, Zach, for taking the time to share with us today your knowledge on the civil cells. We really appreciate it. We want to thank everyone else for taking the time to spend time with us and being patient with our technical difficulties. The recording and the Q&A, any questions that weren't already answered will be compiled into a Q&A document, and the recording should be posted within about a week or so on our website. That's fdot.gov/CAD. And to the right of that page, under the most requested, you'll find the link to the FDOT CAD posted webinars, and that's where you'll find both the video and the Q&A document. So once again, thank you all for being here, especially thanks to Zach for sharing with us today, and I hope you all have a wonderful day. Thank you so much.
Yeah, and if you guys, I have on this web page, on the YouTube page, I have a driveway civil cell video that kind of goes more in depth into actually creating civil cells, and I think that's a good reference to use if you want to start creating your own curb ramp civil cells. You can use some of the methodology in there to help you create curb ramp civil cells too. So thanks, everybody.